Okay, addition rules for probability and the word mutually exclusive and what that means. Okay, so first off, we need to, what I have here to kind of understand mutually exclusive and what that means, I have here all the cards in a standard 52 card deck. So that's every card for ace, 2, 3, 4, 5, on up to jack, queen, king. And so there's 13 clubs, 13 spades is what the second row stands for, 13 hearts, and 13 diamonds. So for those of you that are unfamiliar with cards, there's our sample space right here. So sample space for a deck of cards. Okay, so that's everything. So I'll try to make this as visual as possible. So let's say we had three events. Event A is drawing an ace. And event B is drawing a king, and event C is drawing a club. So, drawing an ace, so here would be event A, if that occurred. Those are your four choices. Event B, maybe in green here, would be that one. That's drawing a king. I'll put a little B here, a little A over here. And then event C, which we'll do in red, would be all the clubs at the top row here. So there'd be 13 different samples in event C. Okay. So if we want to find, so let's say we wanted to find the probability of A or B. So the probability, the key to this is the word or. Or means to add them together. So, and I guess I forgot about mutually exclusive. So let me go back and tell you about that. Mutually exclusive means there's no overlap. So A and B have no overlap. There's nothing in common between the two. So there's four kings here. There's four aces over here. There's nothing in common. Those are mutually exclusive events. If you have non-mutually exclusive events, that would be if there's some overlap or some things in common. So like if you notice here between B and C, there is a king of clubs here. I'll X out. So um, B and C are not mutually exclusive. And the same with A and C. If you notice, A and C gives us an ace of clubs there. So those are not mutually exclusive. And we'll talk about the probability of that in just a minute. Okay, so there's that part of it. So let's go to the events that are mutually exclusive. If they are mutually exclusive, it's fairly easy to figure out the probability. You just add the two probabilities. So this would be, since these are mutually exclusive events, an ace or a king, we can just add the two together. So it would be probability of A plus the probability of B. So we go back up to our deck of cards, and you can count. There's 52 cards in our sample space. There are 4 aces and 4 kings, so you would know that that's 8 out of 52. Or the probability of drawing an ace would be 4 out of 52, plus the probability of drawing a king would also be 4 out of 52. And so that would be 8 out of 52, which reduces to, you could take a 4 out, 2 out of 13. And so there's the probability of drawing, 2 out of 13 is the probability of drawing an ace or a king. So now let's look at the situations where they're not mutually exclusive, because they're a little more interesting to me mathematically. I'm going to shrink this a little bit. So I'm running out of room. Okay. So the probability of A or C. So if you remember, was A was the chance probability. It was drawing an ace. C was drawing a club. So in this case, the probability of drawing an ace plus the probability of drawing a club, C, runs into some problems because what you've basically done is if you can imagine, there's an ace of clubs here in this set, because there's 4 aces, and there's an ace of clubs in this set of 13 clubs. So we've counted the ace twice when we did this. So we've got to subtract one of those off. So the probability, we need to subtract off the probability of A and C occurring at the same time. So we can get rid of those. And so visually, if you go back up to our sample space, here's our 4 aces. So there's our sample space for A. Here's our 13 clubs. And notice when you count the blue and the red, you counted this one twice. So we've got to subtract one off because you counted it twice. And so this event would look something like this. And so probability of A is 4 out of 52. Probability of choosing a club is 13 out of 52. Minus the one overlap, so you can eliminate one of those that we've counted twice. Minus 1 out of 52. And so 4, 13 is 17, minus 1 is 16 over 52, and you can simplify that, take a 4 out, and so you'd have 4 over 13. So that's the probability of drawing an ace or a club. And then the bottom one would be king or a club, and it's pretty similar because there's 4 kings. I should have picked a different example. And I guess I have time. Let's not do that one because it's exactly the same as the last one. Let's do a different one. Let's add an event E here, and let's call event E red cards. Okay, so half the deck is red cards. And let's do another event. Let's call F black cards. Okay, so these two events, you could easily see the top half is your black cards, the bottom half is your red cards. And so let's find the probability of A, which is an ace, or E, which is red cards. So we want to know the probability of drawing an ace or a red card. Alright, so we got a lot of overlap here. Okay, so here's our aces, and I'll maybe circle our red cards in black. There's all of our red cards. I'm going to have this thing circled a whole bunch of times. And so we have 4 aces, and we have 26 red cards, 2 groups of 13. And we've counted this ace and this ace twice if we calculate the probability. So we're going to have to subtract those 2 off because they occur at the same time. So it would look like this. Probability of an ace is 4 out of 52, plus the probability of a red card, which is 26 out of 52, minus the the ace of hearts and the ace of diamonds, which are red, minus 2 out of 52. And so this is 28 out of 52. And that reduces, you can take a 4 out again, so that would be 7 over 13. So got just a little bit more than a 50% chance of drawing an ace or a red card. And so that, I think that's where I'll end. You could do the same with dice. I guess I have the black cards there, but I think you probably got the handle of this. You could do the same with dice. And so let's get our sample space for 2 dice. There it is. Okay, so here's if you rolled 2 dice. Okay, and let me pause this and I'll throw up a problem so we can kind of see this in action again. Okay, so let's say we have this set of dice, and we want to roll a sum of 7, which has some significance in dice rolling. And if we do that one in, let's do set A in red here. So 7 would be this diagonal right here. 6 plus 1 is 7, 5 plus 2, 4 plus 3, 3 plus 4, 1 plus 6. And so let's find the probability of A or the probability of B. Okay? Now, and I'm going to say, I'm going to be very specific here and rolling 2 evens, okay, for event B, so that we're not getting confused there. So both dice have to be even. We'll do that one in green. Okay, so both dice are even. You got one here. You got one here. You got one here. So far I haven't overlapped there. None there. You got one here. You got one here. You got one here. Here, here, and here. So that's the probability, or that's the rolling in the even. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them where they're both even. Okay, so that's the evens. And then C is rolling a 3. We'll do that one in blue. So rolling a 3 is everything in this row and everything in this row. Or everything in that column and everything in this row. I guess that doesn't count, that doesn't count. So, and just be careful that you don't, count the 3, 3 twice. Because you've got, so we've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those. So maybe I should keep track of that. There's 11 of those, 9 here, and a sum of 7. You've got 1, 2, 3, 4, 5, 6 of those. And there's 36 possible combinations. So if we want to go back up here to A or B, those are mutually exclusive. A sum of 7, every one of those has an odd number. And so those are mutually exclusive, so we can just add them. So it would be 6 out of 36 for the sum of 7, plus 9 out of 36 for having 2 even numbers. And so you add that together and you got 1536. This is the probability there. And I'm running out of time, but that would reduce because it's really bothering me. You can take a 3 out and that would be 5 out of 12. So that's your probability of rolling a sum of 7 or rolling 2 evens. Okay, so let's change it up and show one that's not mutually exclusive. So they overlap, like B, let's say A and C. So the probability of A or C, excuse me, not the word and, that would mean multiplication. So the probability of A or C, in our case, probability of A is 6/36 plus the probability of C is 11/36 minus all the overlap. And all the overlap, everything that's overlapping, is we've got this one here, let's see, yeah, this one here, this one here. It looks like just 2 of them are overlapping. So minus 2/36. Okay. And so this would add up to 16, 17, it would be 15/36, which would reduce to, you can take out a 3, which would be 5 and twelfths. So, hope this helps. I'm out of time. I kind of went fast and probably made some mistakes. Here's your challenge. If I made a mistake, make sure you comment or email me and tell me how stupid I am. But thanks a bunch and see you next time.